Hello, sir. Hello, sir.
Fine. Now, so this question, did you solve it?
Yes, I completed this question completed. Two.
Fine, fine, fine. Now, electric field due to infinite line charge. Okay. Now, how to calculate electric field due to infinite line charge? Infinite line charge is nothing but uniformly. Here, if you will calculate the total charge, then total charge will be infinity because the charge is infinite. Line is infinite. So, what we take here, we will take linear charge distribution, means charge per unit length. How much charge is there in 1 meter length of this wire? That is called linear charge density. So take it down. Consider an infinite line with uniformly distributed charge. Okay. And let its per unit charge be lambda. If lambda is its per unit charge, is its charge per unit length. Lambda is its charge per unit length. It means what? It means 1 meter of this wire will contain lambda coulomb of charge. Got it? Shall we proceed?
Sir, got it, sir. Yes, sir.
Fine. Now, to find the electric field, what we will do? We will consider a very, very small, tiny element. Very small, tiny element we will consider. That tiny element is here. This is that, oh my god, this is that tiny element. Okay. DL. DL is the tiny element of this wire which we are considering. Now this DL is the element of charge. It is element of wire. It must be containing some charge. Let the charge on element be dq. Dq is small element of small charge. Now what is the dq charge? We know that 1 meter is having lambda coulomb. Then DL meters will be having how much coulomb of charge? DL into lambda. Lambda DL coulomb of charge it is having. Got it now?
Sir, got it.
Okay. Now therefore field due to this DL charge at point B, this due to this DL charge at point P will be what? Field due to DL will be like this. It will be in this direction as well as in this direction. But what will happen? The opposite components will cancel out each other. Only horizontal component will remain now. Only horizontal component will remain now. So the field, net electric field is KQ upon R square, where R is the distance between DL and point P. Now, in place of dq, just write lambda dl upon R. Now we know that for every dl in the upward direction, there will be another dl in the downward direction which will cancel the vertical component of field. Vertical component of field will be cancelled out because of symmetry. Okay. So for every dl at any point A, there will be a symmetric point B as shown in the figure. This is point B and that is point A. And both of these points, they will cancel each other's electric field. Therefore, the total field will be given by what? Adding all the x components of the field. Adding all the x components of the field. So when you will add all these x components, what you will get? You will get just dE cos theta. dE cos theta. Okay. Now there is one loophole in this. How to solve ahead? for that we can proceed with two ways. I have taken the way of trigonometry here, that would be more easier. Okay, so this electric field is what, dE cos theta. Now in this triangle AOP, in this triangle AOP, what is tan theta? Tan theta is opposite upon adjacent. What is opposite here? Opposite is L, and what is adjacent? Adjacent is here X. X is the adjacent. So opposite upon adjacent we wrote. Hence L we got as X tan theta. Differentiate it. What you will get? dl will be equal to X sec square theta d theta. Differentiation of sec square tan theta is sec square theta. We know that. Yes, Hemant. Am I audible? Is it clear?
Sir, it is clear, sir. You're audible, sir.
Fine, fine. Now cos x, we know that cos x is adjacent upon hypotenuse. So we wrote that cos x is equals to adjacent upon hypotenuse. And what is r? R is equals to x upon cos theta. X upon cos theta is what? That is x sec theta. Got it? Now we are having electric field as this dE cos theta, k dq upon r square cos theta. It means k lambda dl upon r square cos theta. Now this cos theta, we are writing it as x sec square theta d theta. We are writing cos theta as that. Got it now?
Sir, got it, sir.
Hello, yeah, am I audible?
Sir, you're audible, sir. Got it, sir.
See this? Instead of dl, I am writing this. Instead of r, I am writing this. dl was what? dl we calculated from here. dl is this. X sec square theta d theta. Okay. And what is r? What is r? R is equals to x sec theta. So r square we will write x square sec square theta, and dl we will write x sec square theta. So instead of dl I wrote x sec square theta d theta. Cos theta is outside here. X square sec square theta is written here. So sec square theta is cancelled out. 1x is cancelled out. What is remaining? K lambda by x cos theta is remaining. K lambda by x cos theta d theta. Now we will integrate it from minus 1 by 2 to plus 1 by 2. Minus 1 by 2 for what? Minus 1 by 2 because when we will look to the infinity here in downward direction, we have to look right downward. That is minus 1 by 2. And when we will look here at the upper infinity, we will look in upper direction like this. That will be plus 90 degrees. Got it now?
Yes, sir.
Now
Got
we
it,
will
sir.
integrate that. Integration of cos theta sin theta. We'll put the limits. Ultimately, we will get 2k lambda by x. This is the answer. Take it down now.
Sir, copy it, sir.
Copy. Now, if it is of finite length, if this is of finite length, you need to write it down. Write it down.
Sir, I copy it. I'm copying with you, Mr. Noor.
Fine, fine. So,
I'm
when the wire is of finite length, means the
even.
length is given to you. It is not infinite now. Okay, then how to find the electric field and what will be the derivation? This derivation is asked in boards. That's why we have to study all these derivations. Okay. Now, finite length. Now, let this line charge is having a uniform linear charge density, that is lambda. What does it mean?
Refresh another.
It means that here we are not taking full charge, whatever it is, on the full line. We are just taking linear charge density, means charge per unit coulomb. Okay. Now lambda is given to us. Again, we will consider a very small element. Very
6 months
small
మనకు
element.
ఉండలేదు కదా
Okay. DL. We are considering
వాళ్ళు
it
కదా
to find out electric field on point P,
ఏంది
which is at a distance x from the line.
నువ్వు
Okay.
ఎండాకాలం ఎందుకు పెట్టుకుంటున్నావు
Now, because of this DL, there must be some field on point P. What is that field? That field is DE. Okay. That field is DE. Distance we already assumed x, and from DL we assumed it to be R. Okay. Now let the line joining two ends of the line to the point P is making an angle theta1 and theta2 with the horizontal line at P, just shown in the figure. Consider a small element dl at a distance L from point O. Now charges on this element are what? Lambda dl, that is equal to dq. And due to this charge, electric field at point P will be what? Due to this charge, electric field at point P will be again same k dq upon r square. Now what is r? For r we will use Pythagoras theorem, under root of L square plus x square. And when we will square it, this under root will disappear. Only x square plus L square will be remaining. Now again, same as the previous case. In triangle AOP, this triangle AOP, again tan theta is equal to L upon x. Tan theta is equals to what? L upon x. Or we can write L is equals to x tan theta. If we differentiate, we will get this. dl equals to
ఏమైందిరా
x sec square theta d theta. Cos theta here is x by r. Same as the previous case, r is equals to x sec theta. R will come on this side. Getting it? And cos theta will come on this side. So x upon cos theta, we will get. X upon cos theta is x sec theta. Therefore, the electric field will be k lambda dl upon r square. Put the value of lambda, x sec square theta d theta from here, and put the value of r square. R is this one. So put the value of r square, that will be x square sec square theta. Okay. So finally we are getting what? Finally we are getting dE k lambda by x d theta. Now again, this dE will be having two components in x and y directions. Okay, dE in x direction, dE in y direction. In x direction it is cos theta, and in y direction it is sin theta. For x direction we will integrate this component, x component, and for y direction we have to integrate y component. When we integrate it from theta 2 minus theta 2 plus theta 1, then what do we get? Then integration of cos theta will be equal to sine theta. So we are getting field in x direction as k lambda by x sine theta 1 plus sine theta 2. Sine theta 1 plus sine theta 2. Got it now?
So got it, sir.
Now similarly, for y direction you need to integrate whatever field is there in y direction. Whatever field is there in y direction, you need to integrate. Got it? Similarly, just like the previous one. Okay. You will get the field. Take it down now.
అమ్మా సార్ కాపీ ఇట్ సార్
Done. Okay. Now there is one special case from this result. Always remember that net electric field will be what? Net electric field will be sum of these two electric fields, will be sum of the two electric fields, a vector sum of two electric fields. That will be given by what? That will be given by Pythagoras theorem. X square plus y square. Okay. Next one. If the line is semi-infinite, means infinite but standing only up to one direction, then what? Then then we will be having again two components, and just put in the previous component the formula which we derived for x component of field as well as y component of field. Just put the values of theta in those components. Okay. What will be theta 1 here? Theta 1 will be 90 degrees because line is going up to infinite. And what is theta 2? Theta 2 will be 0 degrees. Got it now?
Sir, got it, sir.
Now, this is very important. Electric field due to a uniformly charged circular ring. How to calculate that?
Electricity, string. Sir,
Just a
why,
minute,
sir,
just a minute.
everywhere we are sir, why, sir, everywhere we are considering only positive charges distributed along the ring like that? Yes.
That's a standard. That's a standard. Actually, positive charge is not distributed. Actually, only electrons are there. But earlier, what we what we assume that positive charges are flowing, negative charges are not flowing. Later on, we came to know that no. Actually, positive charges are always inside the nucleus. It is the negative charges which are flowing. That's why what we took. But even then, we did not change the direction of current because we took if electron is going in positive direction, means right hand side, then the positive charge must be going in left hand side direction. So the case was simplified. It is positive charge means what? It is having lack of electrons. That's it. Nothing else. Okay. Got it?
Yes, sir, got it.
Hello. Fine.
Sir, got it, sir. Yes, sir, got it.
Fine. So electric field due to uniformly charged circular ring. How to calculate electric field due to uniformly charged circular ring? In a circular ring, radius is always constant. We know that. So let us assume that the uh, this ring is having a charge q which is distributed uniformly on the circumference. Okay. Again, we will take a small element. Again, we will take a small element that is of charge dq. Now we will find electric field into this element at point P. Okay. Write down till this point and draw the diagram. Draw on the diagram.
Sir, don't, sir,
Fine.
copy.
Fine.
చెట్టుకి చెప్పులకి
Now, how
సంబంధం
to
ఏంటి?
calculate the field? Again, we will consider a very small charge element dq. a small charge element dq. That small charge element will be having its electric field at point P. Okay. And that small field will be equal to what? Kq upon r square. We know that. Q is dq. But we know that this electric field is in two directions, x direction and y direction. Similarly, an opposite charge dq we can imagine on the opposite side of that dq charge. That will again cancel the vertical component, and we will be having only horizontal component left with us. That horizontal component will be dE cos theta. Okay. dE, now put the value of dE and cos theta. Cos theta here in this triangle, what will be the cos theta? Cos theta will be adjacent upon hypotenuse. So x upon r square plus x square whole under root. So we are getting kx r square plus x square to the power 3 by 2 integration of dq. Got it? And when we integrate dq, what is dq? dq was a small charge on the ring. If we integrate it, we will get full charge. What is full charge on the ring? Full charge we assumed as capital Q. Okay. Full charge we will take as capital Q. So what will be the net electric field? Net electric field will be kqx upon r square plus x square to the power 3 by 2. Got it now? Got the points?
Sir, got it, sir. Sir, got
Tell
some
me when
copy.
it's done. Done?
So copy it, sir. Sir, done, sir.
Okay, okay. Fine, fine. Now some important points regarding this ring. If x is very, very larger than the radius, then what will happen? Then we will ignore radius. Then we will ignore r square. What we will get then? When we will ignore r square, only x square will remain. X square to the power 3 by 2. That 1 by 2 and 2 will cancel out. Only x cube will remain. Ultimately, we are getting kq by x square. Kq by x square we will be getting. Got it now? Only kq by x square will be remaining. It means what? It means the ring will be acting as a point charge when the distance is very, very large than the radius. Next, at the center of the ring, when x equal to 0, what will be the electric field? Electric field in that case will also be 0 because it is directly proportional to x. kqx upon r square plus x square to the power 3 by 2. Okay. So, what will be the answer? If radius is very, very smaller than x, then what will happen now? If radius is very, very smaller than x, then higher power of x we will ignore, means x square we will ignore. So we will get kqx upon rq. Got it now? Taken down the points?
Sir, copy it, sir.
Fine. Okay, then solve this question now. At how much distance from the ring the electric field will reach its maximum value? Solve it now. From for how much distance from the center of the ring electric field will have its maximum value.
I'll give my say. So we can say R by 2, we can say, no, so we can differentiate and equate into 0. I can get this.
What did you say?
So we can say at the set of R by 2 it is maximum, we can.
At r by 2.
Root
R
2,
by 2
sir.
or r by root 2?
Root 2, sir.
At r by root 2 it is maximum. But how to get that? We
So by
need to
differentiating this
differentiate it.
equation, yes,
Yes,
sir. By
yes, yes.
differentiating, you
Yes,
repeat
we
again the name, sir.
differentiate it. We'll equate it to 0. We will equate it to 0. And finally we will get a point. At that point there will be maxima or minima. Okay. Maxima or minima. Now, how can you find it as maxima or minima? Again differentiate it, and if you will see, check if you will see positive and if you will see negative. Positive you will see when x is positive, and negative you will see when x is negative. That's it. Okay. So the electric field will be maximum and minimum like this. Got it now? And
So
what will be
got
the
it, sir.
magnitude of maximum electric field? For magnitude of maximum electric field, just put x equals to r by root 2 in the formula. X equals to r by root 2 in the formula, you will get the answer. Now, most important one, electric field due to uniformly charged segment of the ring. Again, now consider a segment of ring. It is having a radius r and it is subtending an angle phi at the center. Lambda is its linear charge density. Therefore, electric field at the center due to the small segment will be what? K dq upon r square. What is dq? Lambda dx upon r, lambda dx. So k lambda dx upon r square we are getting. Now we know that theta is equals to arc upon radius. So dx is equals to r d theta. Dx equals to r d theta, that we know. So put dx equal to r d theta here. Here now we got electric field in terms of theta. Now because of symmetry, only horizontal direction will be remaining. All the other components of y direction will be cancelled out. It means what? It means dE cos theta will be remaining. So dE cos theta I wrote down here. What was dE? We wrote down d. Now integrate cos theta with respect to theta itself. Integrating cos theta is sine theta. Upper limit minus lower limit, it will become 2 sine phi by 2. Upper limit minus lower limit, minus phi by 2 to plus phi by 2. So upper limit is plus phi by 2. Minus of lower limit. Lower limit is already minus phi by 2. So minus of minus sine phi by 2. So minus minus will become positive. 2 sine phi by 2 we will get. This is the electric field due to an arc. Arc making an angle of phi at the center. Got it now? 2k lambda by r sine of phi by 2. Okay,
Yes, sir. Okay, sir.
got it?
So got it, sir.
Done. Just a minute.
So got it, sir. Yes.
Hello. Now, similarly, seeing this formula, you can derive the formula for any kind of circular structure. electric field at the center for any kind of circular structure. If the ring is semicircular and you need to find out the electric field, then what? Then phi by 2 is 90 and sine 90 is 1. So electric field will be 2k lambda by r. Got it?
So got it, sir.
Now your homework is to check electric field due to uniformly charged disk and uniformly charged sheet. These two derivations, just try to see them, okay, and then we will continue from there. Got it?
Yes, I got it, sir.
Fine. Okay, then I have to leave now.
Yes, sir. Okay.
That's all for today.
So thank you, sir.